Hey everybody, Chris McClure here. Now we turn to section 1.3 out of the textbook, where we will talk about the different types of data that you could potentially collect when you are doing your statistical study. Okay, just a second, please. All right, so remember what we talked about last time, in that when you do a statistical study, you typically take a sample from the population. And remember that a sample is just nothing more than a subset of the population. And of course, you want your sample to be representative in some way. We'll talk more about sampling later. But in order for you to have any hope of a good outcome, in order for you to say something intelligent about the population as a whole, you'll want your sample to be representative of the population as a whole, so that the results of your study can be used to make inferences about the entire population. Later on in the course, we'll talk about inferential statistics. But we need to nail down some specific definitions regarding data, because if we don't get our data right, then nothing else is going to matter. All right, so our first definition is parameter. A parameter, as you can see here, it can be defined as a numerical measurement describing some characteristic of a population. For example, population mean, population standard deviation. Mean and standard deviation are two parameters that we would oftentimes want to estimate using a statistic. Statistic comes from the sample itself. We will most likely not know the true value of the population parameter, but we can estimate it using the statistic. So for example, when we take a good sample of, say, snakes, and measure the snakes, as in measure the length of the snakes that we catch, then we can say that the average length of the snakes in our samples will be close to the true population average of all the snakes out there. Again, it's not practical for us to be able to catch every snake out there in the forest. But again, if we have a good sample, our sample statistic will be a close approximation. And of course, the better our sampling technique and the larger our sample size, the better the estimate's going to be. But a statistic is to sample as parameter is to population. Now, regarding the data itself that we collect from our sample, there are a couple different types here. There's quantitative data, which is numerical in nature, represents counts or measurements, as in, for example, weights of models or snakes or cats or salt shakers or bananas or whatever you can think of, or age of respondents, or number of M&Ms in a pound bag, or whatever. Okay, so it's just numerical in nature. The other type here is categorical, otherwise known as qualitative data or attribute data. Now we're talking about names, labels, so for example, colors, sizes, preferences, whatever, genders, shirt numbers. Now when you see shirt numbers, as in jersey numbers for, say, a football team, even those are numerical, but those numbers are labels and not counts or measurements. Okay, so if it's a label, then it's categorical. If it's a count or some sort of measurement, then it's quantitative. Now, we're going to focus on quantitative right now. There's two different flavors of quantitative data: discrete versus continuous. Now, discrete, we're talking about data that could belong into only certain categories, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Though maybe they can be only integer values. But if your data could take on any number in a range, so for example, the length or the width or the height, then that's continuous versus discrete. So, for example, the number of eggs that a hen lays, that's an example of discrete data variable. Or the amount of milk that a cow produces per day, well, that would be a measurement on a continuum. Now, we're going to talk about levels of measurement. Now, there's 4 different levels here. There's the nominal level, and we're just talking about labels here. We're talking about consists of names, labels, categories, data that cannot be arranged in any sort of ordering scheme. For example, if you are asking someone if they support the Affordable Care Act, yes or no or undecided, those are the 3 possible outcomes for each sample. Well, there's really no practical way of ordering these responses. So this is the nominal level sort of data here. Typically, categorical data is going to be nominal or ordinal. Ordinal, there actually is a sort of natural way that you can order. So, for example, if we're talking about grades, letter grades that you can earn from your schoolwork, naturally A is better than B, and B is better than C, and so forth. Or, hey, how about jersey numbers for the football team? You could order them from smallest to largest. Now, here's the third level, the interval level, which is more of the quantitative type of data, in which they're numerical in nature, they can be arranged in order, and the difference between the numbers could actually be meaningful. You know that there's a greater distance between 1,000, 2,000 compared to the difference between 1776 and 2000. For example, that's different than that second level, ordinal level, where we could order these data values here, but the difference between an A and a B, we don't know how that compares to the difference between B and C, or between C and D, okay? But the differences between these interval level type of data are actually meaningful. And then finally, our fourth level is the ratio level, in which we have the interval level together with a natural zero, as in the prices of textbooks. We know that what zero means in this context. It means a textbook costs $0. And then maybe some other textbook costs $100. Maybe some other textbook costs $50. And we could see that the difference between these two textbooks, 50 versus 100, is different than, say, the difference between two textbooks that cost 100 and 175. And also there's a natural zero. So ratio level has a natural zero versus the interval level where, there's really no natural zero here unless you want to talk about the year zero. But that's just more of a reference point. That doesn't really mean anything. We don't really know what the beginning of time is. Okay. All right, so these are the different levels of measurement that we talked about. The nominal and ordinal are more for the categorical type of data. Sorry about that, categorical type. And versus the interval and ratio, which is more for the quantitative type of data. So here's a summary of what these levels of measurement really are talking about here. And with that, that's it for this section, and I'm going to be done with this video. Keep it a short one so you can get started with your weekend. 3-day weekend this weekend. Today is Friday the 23rd, so we have a 3-day weekend. Campus is closed next Monday. So I'll be back in the office on Tuesday and putting up another video, okay? Make sure that you've got registered with my stat lab and that you're starting to work on the homework, okay? And let me know if you have any questions about anything. I monitor my email over the weekend, but please don't try to call me because I don't typically carry my phone on the weekend. Okay, but if you need to leave a voicemail or something, that's fine. But prefer an email. Okay, so have a good weekend, and I'll talk with you next week. Bye.